All right, so if you remember last day, we were talking about the equations of motion, right? V is equal to U plus 8T. B squared is U squared plus 2AS. And S is equal to UT plus a half AT squared. And then we have the next one and this one as well. Velocity is displacement in time. Right? I left only one with a half U plus V, right? As I told you, these here all have acceleration in them. This does not. Okay? We did one small example last day where you had an object, and we threw the object horizontally, and we said that the part of the object will follow is a projectile part. That's okay? So this part is a projectile part. What we are going to do now, we are going to go a little more in depth. We are going to go a little more in depth into projectile motion, right? And show how we can use these equations of motion to deal with any situation that an object moving in a projectile will follow it. That's okay? Huh? Right? I just give you an answer for 1 minute before we start, right? I just give you an answer. Okay, so we're going to take a look at projectile motion, right? Right. Come on, have start. Oh, it's not all right, so before starting derivation, take a small note. Projectile motion refers to, take a small note one time. Projectile motion refers to the motion of an object that is thrown or projected, into the air. Comma, affected only by what? Very good, gravity. Very good. Affected only by gravity. Affected only by gravity. First up, the object is called a projectile. The object is called a projectile. And its path is called trajectory. And its path is called trajectory. And its path is called trajectory. Projectile motion, that's it. Projectile motion. Projectile motion can be broken into. Very good. Projectile motion can be broken into two components. Can be broken into two components, horizontal and vertical. Right, the projectile motion could be broken into two parts. It's horizontal and it's vertical motion, right? Note that for horizontal motion, note that for horizontal motion, velocity is constant. Note that for horizontal motion, velocity is constant. Why? Why is the velocity constant in horizontal motion? Because now, Diane, why is the velocity constant during horizontal motion? Yeah. Why is the velocity staying constant? Because right, because gravity acts vertically, right? So horizontally, gravity has no effect on the velocity, but vertically, right, gravity has an effect on velocity. So horizontally, your velocity, whatever you start off with, you'll stay the same, right? That component will stay the same. All right. So let me make sure you understand that. Huh? If I were to shoot a projectile here at an angle theta, it will follow a path, something like that, right? Remember, at any single point in time, there is a horizontal component and there's a vertical component. So I put in V for vertical component, right? And it has an initial velocity u. So what I'm saying is at any point in time, that vertical velocity is affected by gravity, but the horizontal velocity is not. That's okay? So at this point in time, the velocity is a tangent, right? Remember we talked about that? Right? At that point in time, the actual velocity is tangent, but it has two components, a vertical and a horizontal. That horizontal component, regardless of where it is, always the same, right? But this vertical component is affected by gravity. Huh? Yeah. You okay with that? So if you look at it carefully, right? See this here? Right? If you remember what we did last week, these vertical components are affected by gravity, right? And gravity is a what? Acceleration. So any calculations I have to do for vertical, I have to use 1, 2, 3. Okay? So you would recognize I will always write vertical motion here because all of these are affected by gravity or acceleration. And this lonely fella here, is horizontal motion because not affected by gravity. That's okay? Right? So just finishing that note there. The horizontal component, velocity constant, and the vertical motion is affected by gravity. Vertical motion is affected by gravity. Online, you're following? Whereas the last temple after. Okay. Yeah. All right. You all ready? So now we are going to take this and find anything we need there. All right. All right. Ready? So, in our scenario here, let's take a projectile. Let's take a projectile and project it with an initial velocity u at an angle theta to the horizontal. All right. So that's what we're looking at here. Projectile at an angle theta, and you project it like that, right? Ideally, this should be a little tangent here, right? A little way over. Right, nice. Let's see if we can find a few things. Let's see if we can find in everything that has to do with the vertical and horizontal, right? So let's start here. What is the initial horizontal component of velocity? What is the initial vertical velocity? How I'll find that? The initial velocity is u. How will I find the initial horizontal component and the initial vertical component? Right, just resolve this, right? Right, horizontal is this way, so that's horizontal. Vertical is this way. So adjacent is horizontal, so that's u. And vertical is? Everybody okay with that?
Yeah.
Right. I want to find the velocity at any point on the path, anyway. So I want to find the velocity there. Right? To find this velocity, I need to get these two and then do what? Find the result.
Yeah.
Resultant, right? If I find this and this and then find the resultant, I'll get B. So let's see if we can find the horizontal component of velocity. Let me see if Jacob was listening. Jacob, what is the vertical what's the horizontal component of velocity here? Yes, plus u plus theta. Why? No, because the velocity is constant anyway. I ain't give you any angles or anything here. Yeah, Pete, you might not write it. It's in the notes, so. By the way, everything I called in on the notes as well. Everything. Yeah. All the elements have the notes and
You can send me the link up. We have multiple elements.
Right. Anyway, so watch here. Right, but when you go through these things and you write them, you just cannot remember them as opposed to me just giving you notes, right? So I'll give you notes for those who really pay attention on things. Right. Nice. So we learned to find the velocity anywhere here. Are you okay with that? So horizontal velocity here, here, or here is always going to be this. All right. But Darian, here's the problem. I want to get the vertical velocity at that point. How are we doing that? Is it constant, Darian?
No.
No. It's changing, right?
Because of gravity.
Because of gravity. But we know everything in this one. I think my answer is now. Right, yeah. Darian. Talk to me now. How we go and find us? Huh? Yeah, how are we going to get the vertical velocity here? Or anywhere for that matter? I talked to you about it at the beginning of the class. But general. We have to use the. Yeah. We have to use the equation of motion. Right? So you want to find B, so you can use 1 or 2. Not 3, right? Why? Right? We mightn't use, you can use this if you have F, right? But let's use this, right? Remember I told you last week?
Can I give a time though?
What? Right? Remember I told you last week? If you're using this equation, every single one of the components must be vertical.
So
Okay?
what's the time?
No, we just leave it in terms of t. So you can leave it in terms of t, or you can leave it in terms of s. Anyone else? All right? But I'll leave it in terms of t for now. So the vertical velocity will be the initial vertical velocity plus acceleration is what?
Gravity 9.8.
But it going up. So negative, positive. So it will be minus g by t. Right? So the formula for vertical velocity could look like this. Right? Initial vertical is u sine. So it could be u sine theta minus gt. That's okay? Or as Marquis was pointing out, we can also use u sine theta. We can also use this minus g, sorry, 2gs. Anyone can work, but your s must be vertical displacement. That's okay. Right? Now you can say that. Make sure you're following. Are you okay with that? So I could use either of these to find vertical velocity, and then for me to actually find the velocity at that point, I just going on to this, right?
Yeah, that's
Right? I'm gonna resolve. Y'all okay with that?
Yeah.
Right? So again, I don't want you to learn this, huh? All I want you to recognize is that we can use this to find anything we need. That's okay? So we did enough things on velocity, right? Just one thing I want you to know, it's in the notes, but yes, you can write it down if you want, right? But now it's here. Do write us here. I want to write four more things.
Time to write that.
I want to write four more things. Right? Here. Note that what happens at maximum height? What is happening at the maximum height here?
Is 0.
Right, nice. Right, remember we did a question on this last, right? Let me stop saying remember, yeah, but last day we did a couple questions where max height, when at max height, v is 0. Right? Just remember that. One last thing before I layer, right? Suppose at that point, I want to find the vertical displacement y, and I want to find the horizontal displacement x. Right? Let's start with horizontal displacement x. How am I going to find x? Nathaniel, what would be the equation I would use to help me find horizontal displacement? Horizontal, eh? Yeah. Go ahead. Yeah, ab initial. Ab velocity anyway. So which one am I gonna use? 1, 2, 3, or 4? But remember I said horizontal, so it has to be 4. So if I make S the subject, it's V by T. So it will be horizontal velocity multiplied by time. Okay? And the horizontal velocity is always U cos theta by T. Okay? Again, I don't know T, but I know it's in terms of T, right? If I find T, then I can find X. No. Go learn this off. Learn just to use that. Right? So the point I wanted last week and this week is to try to emphasize that if you learn this, you can do any question. But you have to understand how to use it properly, right? So since you bring up that point, how I can get y? How I can get the vertical displacement y? Which one you would use then? 1, 2, 3, or 4? Vertical displacement y. Would you use 1, 2, 3, or 4? 2, right? That's an option. That's an option. But it requires you to know B as well. But then you want to bring in this and all kind of thing. So let's go easier and use 3. Right? So the vertical displacement is y, correct? initial vertical velocity by time plus a half by gravity, that's acceleration minus g by t squared. So I'll get y is equal to, this is u sine theta by t minus g t squared. I just put in the 2 underneath here. But I'll leave it here. Okay with that? So if I find time, Darian, I could find y anyway. You okay with that? Right. One more thing that they like to ask us. That's it. They like to ask us to show that this part follows a parabolic path. Parabolic simply means photograph. Right? So I have to show that this part follows a quadratic. Okay? So I already have y, but I don't have x in there. How I can do that, Daniel?
Right. Send it.
So I have y, right?
Yeah.
But I don't have x in here. I want to turn this into a quadratic. How I can do that? No, I want to get y looking like this. So what to do?
So then you get out, what's it called? We did it already, and so you compare.
It's something to do with something on top of it. Can I make t subject here? And I'll get x over u cos theta. And now if I take off t, I can put this. So I'll get y is equal to u sine theta by x over u cos theta minus a half g by x over u cos theta squared. And then if I expand this out, that's a quadratic. Right? I'll give you one more line of work, right? Y is equal to the usual cancel, sine and cos and tan. I just multiplying this out. I'll get minus g x squared over 2u squared cos squared. If you look at this closely, don't worry to use second thing, right? You will see that this is minus g on 2u squared cos squared theta by x squared plus tan theta by x, which is of the form ax squared plus bx plus, right? This is a, this is b, and c is 0. And it's a minus, so what type of quadratic it is? A maximum.
Oh.
Right? So if the question asks you to prove the part is parabolic, yeah, it was. Right? Go ahead, write it down, take a picture, anything you want in your notes, right? Right? But you understand how I got it? All came from here. Online, all okay? Dylan, are you okay with this?
So if that's all right, they're not gonna give me enough time.
No, you can go ahead. So now, I have a worksheet for you. And we're gonna start doing some questions, right?
I printed it,
Well, yeah, yeah, that will take my whole 10 minutes, but too long. Yeah, the same thing you do, right? Right, copy it down and let's go, right? If you don't want to write it, no problem. We'll take a picture, you can go over. As I said, it's in your notes, in the element as well, right? Right, the only problem now is we have 10 questions to do in an hour, right? So better work fast. Yes. So, or we can do more. Fine.
Like you're gonna do. I thought.
Are you ready?
It's a. I don't.
If I just space 9 seconds. If I just space and I'll picture and you can go straight over. Alright, let's start number 1. Actually, we can start with number 3. Anyway, it don't matter. Right, if you're not seeing it, it's in the group. And let's start with number 1. Right, they are not past paper, but it's similar. I just changed them because I don't want to. That's right. But we are going to do this one.
Okay, you know, then you can read enough time to do it. Because number 1, number 1 and number 2, I think number 2. But we draw a diagram.
Right, number 1. Take a little read, write down what you have. No, I ain't doing it yet. Write down what you have and then see which equation you want to use, right?
I draw my diagram.
Yeah, number 1, draw that. How do you draw that? Sorry. I left out that here. What's the diagram? Right.
So not later.
Let's see how much you will get. I might skip out 1 or 2. Right? The first 3 is easy, then medium, then half. But I find it hard to kind. Right, gas income today, Katrina online, Nathaniel, COVID, like Fields, Karina, Shatana.
Get it, right?
Yeah.
A soccer player, so one person to be from a height of
1.5.
1.5 meters.
Yeah.
So he started at 1.5 meters.
Yeah, he on top something 1.5 meters high.
That makes 0 sense. Okay.
He on top of cliff and he kicked the ball off.
I hear that.
Vinesh, Darian, Reese didn't come today. Renaissance. Asgarani online, Javi come today. Brad, Jacob, Marty, well, today. Elijah didn't come today. Elijah, no. Right. Dylan here. Oh, we fucked up. Right, so I'm not doing it. I just point out some of the information that I should already have. Right, online if you finish it, copy answer. Right, see at four here. Take it horizontally. The height here, the vertical height. Right? And well, of course, we know as it falls with gravity, 9.8. It will follow up path looking like that. If the ball lands 20 meters away, so that's all the way down here. Right? How long will it take to reach there? Right? So from what I'm seeing, we have S. We have S vertical, we have S horizontal. We have acceleration vertical. Right? Oh, by the way, it moved up horizontally, right? So what does that say, Nathaniel?
It moves what?
It initially moved up horizontally.
Yeah. It had no displacement, of course.
It had no. That's not what I'm looking for. It had vertical displacement, 1.5. So if it moved up, we did the same thing last week. If it moved up horizontally, barrier, help them out now. The vertical velocity is what? Zero.
Yes.
So then I want to start with this
Yes.
and displacement is not the velocity. Correct.
Right? So we know that the initial vertical velocity is zero. That's okay? Right? So you need to take a time. You're taking out. So you want to get time, and I forgot to ask for the initial velocity as well. How long was it in the air and the initial velocity, right? So I forgot to add that here. All right, so see why it's important to write down what you have, and then you'll be able to narrow it down, right? So how are you getting time? What equation you're gonna use, Luke? Jacob. Sorry. Oh, which one? Which one? 1, 2, or 3? I know, but if you use the horizontal, we don't know the horizontal velocity of that. You're gonna use S is equal to. Okay, yeah, that sounds good. Right, you're gonna find T first and then find velocity. I online, Google it out, message your answers. Take your time, message your answers. Fine. Just watch. Get negative velocity. Good. Can I get time first? Find a zero. Yes. Right?
I don't think I right now.
Well, let me see now. So I just writing down what we have, right? So they want us to find They want us to find time to reach here, and they want us to find the initial velocity, right? Right. What do we have? We know that the initial velocity is horizontal, so the initial vertical is 0, right? We know that this displacement is the vertical displacement. So that's 1.5. We know it's moving downward, so acceleration is positive 9.8. And we know horizontal displacement is equal to 20 meters, right? And they want us to find t. So I'm going to try and find t first. So I'm going to look at my equations of motion, and I have 1, 2, 3 things, and I want to find t. So I have S, I have U, and I have A, and I want to find t. So I'm going to use the third equation there. So I'm going to use S is equal to UT plus a half AT squared. S, vertical, vertical, vertical. I like to do that so that you know that all the components you're using are vertical. Okay? So the displacement here, 1.5. The initial velocity is 0. Acceleration, 9.8. And time, t squared. Multiply, divide, do your thing. And you'll get t is equal to, right? 2 by 1.5 divided by 9.8, then you square root that. Take your time with the subject of the formula, right? What is that? 0.55 or 5? 0.557. Right? Go ahead, ask the question.
No, I got it very wrong because like. And look where.
Without footballer, he's not real.
No, like exactly time now. Like I sit, but you go back to the question, check it out. What
Next thing is to find u.
this place B.
Find the initial velocity.
We will find you. Initial plus B each. You each.
All right. So, are you okay with that? Well, yes. Yes, this is UH because it starts off horizontally, right?
Yes.
Right? Well, you get it? Next one is yours, right? Finish. How again you? How again the horizontal velocity. What you gonna use? Horizontal, right? So which equation here you can use the horizontal? You only have one, right? Horizontal velocity is horizontal displacement divided by time. What's the horizontal displacement? 20. And what's time? 0.55. Right, good job, Katrina.
36.36 meters per second.
36.4 meters. Too significant figure, right? Dylan, you okay with that? You remember you can send all the answer? Dylan and Garage and everybody else online.
What's your time?
That's it for number 1. I send the thing in the group or no? No, I don't go anywhere. Number 2. Number 2. But okay, number 1.
Yeah.
Number 2. Right, one thing going up the skip, right? That's a real nice one. I want to one that really fly. But guy number 2. right? So this one a little bit different.
It's not,
Let's talking, boy.
yeah, but you're gonna end up with you one thing.
Why not just talking? Let's kind of do it. I want to know your opinion.
Say, this is like the example you show us, this like one.
Right, so a cannon fires a projectile 30 degrees above the horizontal, and they give you the initial, what's the maximum height reach, right? That's similar to what we did on the board, right? The big one on the board. Take your time, use the right equation of motion. All right, nice one. So nice. Four is a fast paper. I remember I switched it up a little bit. Right, online. So remember the channel answers. The oh, look at me. No, is this? Sanjeev Mushi.
Yeah, so maybe it's
Hurry up. No, no, his name here. I'll go to name here. Try the thing now. All right. Right, Kabir, it's just like Kabir. Javed. So number two is just like what I did on the board. You proof on it. Number two, just like that. The Daniel, we doing.
so and stuff with no phone.
We're gonna do it.
That'll be good. But we have.
So the diagram of state global. Alright, find the. No, that's not the initial vertical to give it. Yeah, to find the parts of four times. Like a little. Oh, good. Or no, it's okay.
Yeah.
And then what is happening at maximum height?
Yeah.
So now you can why you put that back on that. Put make it things like. If you know the vertical, if you know the final vertical, and you work out the initial vertical, how you can get S. But what you could do that you set the finance. Right, you have U, you have V, you have E, and you want to finance.
That's not.
Which one? You have U, you have V, you have E, and you want to finance.
Oh, yeah.
Right, that's all you do. Right, but we had which all before. So. Yeah, so it becomes because it's not like the last one where horizontal. Now.
Wanna read
Do that again. If you're finished, you have to go ahead and do 3 and 4, right?
it?
Please, like, one number. Page number 2. Play again.
I'll go and sit,
Yeah.
So Dory, I've done the correct one, I checked the answers, Feel get happy there,
Huh?
feel get happy there.
Don't need answer. I put it,
I get that.
I put it there for people who want to finish it.
Now, what's your answer to this? What kind of answer do you want?
You get us? So you're doing question 3, right?
Yeah. I can answer 2 that's now.
So if a person throws a stone, if somebody throws a if somebody throws a stone horizontally, that means it goes like football, so and so, right? Alright.
What's the angle again?
50 degrees.
Right? For those who are online, the diagram might look like this. You shoot a particle 50 meters per second at an angle of 30 degrees to the horizontal, and you want to find the time. No, you want to find the maximum height, and at maximum height, V is 0. So we should remember that we can't use 50 why? We can't use 50 because 50 is neither horizontal nor vertical, right? So I need to get the horizontal component, which is 50 cos 30, which is 25. No, sorry.
It would be
But we don't need that, right?
vertical.
We need vertical, which is 50, which is 25. Okay? So it's 25 meters per second. Now, I know the vertical velocity. I know the final vertical is 0. I know acceleration is what? Minus gravity, so that's minus 9.8. And they want me to find S. So Nathaniel said to choose equation 2. Right? So he said to use V squared is equal to U squared plus 2AS. Again, I like to put vertical, 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 vertical. Right? Because I'm using the vertical components, right? So the vertical component is 0. The initial is 25 minus 2 by 9.81 by S. Make S the subject of the formula. You'll get 25 squared over 2 by 9.81. Okay with that? How much is this? 31 point.
9.
Right? So you all follow, you can do anything with these equations of motion. Once you have that, that's all you need. Okay? Go again, try number 3.
So after number 3, we're gonna have number 4.
I'll really go from 5 and then 6 and 10.
So do number 4.
Huh?
Do number 4 or do number
Yeah, do number 4. Right, let's check out online. Yeah, use 9.8 pillar. Right, well, we have Katrina who always sending us. Katrina who always send my. Thank you, Katrina. Because of you, you're the reason why I still have online. I was stuck online so far.
My
Say that when you say I can.
I know.
like will get back up around and
No, but the Tilan sending answer. Kieran is sending anything. Barrage. And then we send him a blood pressure. Come on, they send me some answers. Be like Karina and Dylan. Katrina.
Hey, stop singing. And I'm trying to go.
So I think you should put the teacher on this section.
You get no P.
Anybody here not on the elements? Not. That here, go to one of it. Right, when I got the email the first time. Check for your email. The email is what will give you the link for it again.
Why are you gonna tell me?
You're getting that number three is supposed to be real easy. Right? Number three is supposed to be real easy. Right? Because what they give us? They give you a horizontal speed initially, and they gave you time. And they wanted to find horizontal. What's up? And they wanted to find horizontal distance, right?
Yeah.
So S is equal to V by T. Right? V is 5, T is 2, so that's 10. That's all? Nothing else? Because we have everything horizontal, right? Right? So sometimes you'll be surprised. That'll be a hardest question because you overthink it. Right? But it's real simple. Right, good job, Katrina. Well, Tira. Huh? Come on, give me any. Oh, we're going to food. Come here, sir, honey. Oh, yeah. Yeah, try number 4. Sorry. When I sit down doing nothing, that's what happens. Come on, do number 4. Right? Pull out the number. I'll tell you which number after, right? Right? When you finish 4, I think you can handle 7. So try 7. Pull the pencil one first. So that's what I make again. No. Who doesn't make again? Oh, there you go. No one I would think I explain more. Something sour. When there's money, right? When there's money. In a way, right? Like, what's that? That's the point, but I don't know what's so hard. No, we can reach out, give that half to finish about last 5, don't make it 5, 6, what a 5, 6. Huh? And most streets, I can log in on your phone, you get it on it. I'm sure you have it. It's somebody are you right? Oh, you have to try number 4 and then try number 7.
I only find an A and U.
4 and 7. Sorry?
Number 4. I only get an A and U. Well, stop.
I don't mind carry it.
So in the exam, they would tell you, assuming application, acceleration, like this one.
So give it about 9.8 I use in here. Yeah, when I work it out, I use like the absolute back 9.8 I use.
As he said,
It's like keep normally 9.8. But it's very slow. Yes, look at it together. They'll tell you. Yeah, at times that even like 10. To give you a nice value. Yeah. Good enough. Number you want. 4. 4 a little different. All the time to blow hard and do nothing. I do nothing, you do your
this
thing.
one option here is similar to
Number 4.
Hey, you listening?
What?
No, right.
Number 1 and number 4 is not the same thing, huh? Not the same diagram, huh? Number 1, number 4 is not the same diagram.
Hold on.
Camille coming in here this too, with all of them. Right, number 4, a person standing on a 45-meter high. Right, I just joined the diagram here and I'll take off the question, right? Choose a ball, but you're throwing the ball at an angle
40.
of 40 degrees with a speed of 25.
You can take out what we have and then stop.
Right? How far from the base of the cliff does the ball land? So they wanted to find here, I'll just call it R as usual, right?
I don't know. Take out what we have.
Sorry?
Take out what we have now.
Take off one.
Take out what we got.
I mean,
Like from what they get the question.
Yeah.
Take out all the stuff that they give us.
right, well, look at here. Right?
A is negative 9.8. Yeah, time
Right,
first,
so-
right?
First thing, you want to get R, right?
You wanna get R first?
No, I just say you want to get R. R is your horizontal displacement, which is equal to your horizontal velocity by time. We have none of them. So we need to get horizontal velocity and we need to get time.
Get time first.
Right? Yeah. I just saying. Right. What do we have?
We have acceleration and initial velocity.
Right? We have acceleration. It's time to go upwards first, so that's minus g. What else you have?
Initial velocity 25 sine.
Now, but we can't use, all right, so we have initial horizontal and vertical. So initial horizontal is how much?
25 plus.
25 cos 40. And vertical is 25
Sine.
40. What else we have? What is this here?
That's displacement.
Right,
Horizontal
this is the most important thing in the whole question. We know the vertical displacement. What's the value? Now,
45 plus.
look at where you start. Look at where you finish.
Wait.
Look at where you start and look at where you finish. Huh? What is it? Minus. What the last word? Minus. Alone? As well as saying minus.
That's what I'm saying.
Minus.
Yeah.
Okay. So the answer is minus 45 meters. Right? Why?
You're going down one.
Because it starts here and it went below the starting point. So it's minus 45. Okay? So we have this, and this. And we need to get this. Which equation we got to find t diagram? Right? We have 1, 2, we have all of this here. Well, we don't only this out here. Right? We have this vertically, we have this vertically, we have this. So you're going to use 3. Very good.
I can stop right there.
Right? So we are going to use S is equal to UT. Right? You'll follow why this is a minus. As in, if you use a plus, you'd have gotten it wrong, right? It's important. Now you know it's a minus, right? Online, all okay? Dylan? All okay with that? Okay, when I did grades, I would get to do all 10. Right? But if I had 5, I didn't get to do the homework, please. So SB is negative because of what? Oh, the reason it's negative is because we start here, went up, we came back down. If you stop here, all the displacement here is positive. Once you go below the starting point, your displacement is negative. On the opposite side, right? Remember, you're starting here, you reach here, so your displacement is 0. Everything here is positive. Below your starting point, everything is negative for displacement. Oh yeah, find T, find R, and we have one more to do. So yeah. Hurry up, hurry up. Right, since we're in motion, we have two other things to consider next week: terminal velocity and circular. Right? Have no class in the includes, right? That's what it's there. Huh? Who's gonna run? Yeah. Right. That's right.
And you're gonna put one step to leave it on, like, but they like to run it.
Yes.
Just remind them the exact hits online to 74 sleep personal chats. Right? They have to send them by next week, Saturday, the latest.
She has a name, right? I want to message her privately.
Yeah, I have been to get registered with us.
Did you get names out?
Yeah, but some of them is just.
Some of them don't.
I think it's- You also think you're gonna.
Yes, she was in the class.
Yeah.
All right, let's see. So we have minus 45. Initial vertical velocity is 25 sine 40. How much is that? 16.1 by T plus a half. Sorry, well, I'm putting the minus one time, right? A half by 9.8 by T squared. Right, bring it across, solve it, you'll get quadratic, and the value is what?
5.1.
5.1. Yeah. Try to round up too much, right? If you round up too much, the answers I got at the end, you wouldn't get it, right? Might be a little bit off. So let's try to round up too much. 5.1 seconds.
I can do.
Right, so there's a quadratic, go straight to calculator and solve it. And now we can find R. R is equal to 25 cos 40 multiplied by 5.1, which is
I get 97.67, but I was wrong for your answer. Your answer was 120.
for this one,
Yeah,
1.
your answer is 120,
So this is how much?
but I get 97.67 back.
And how much you got here?
5.1.
I think here I would have used the exact value probably. Work it out. Huh? No, within our range, I find 120 as far.
Yeah, let me do it so once.
Check back here from and see. Maybe, because I kind of rushed them off myself. But I know for sure I use the exact value here. So I use 25 cos 40. Sorry, 25 sine 40.
That be wrong.
This is what? This is 25 sine 40, right? Yeah,
Negative 4.9
and
squared, like 16.1 and 40, plus the 45 favorite,
yeah, yeah.
and you get negative 1, which can't be right, and you get 5.1, 5.0.
5.108.
5.08.
Okay, all right.
5.1,
And then here would be what? 25 cos 40.
and you get 90 something.
All right, yeah, well, it's close. Well, not close, but 97.1? 97.67. All right. I'll check it back up. I'll start checking. It's new worksheets are doing over.
97.6.
Alright, go again, number 7.
I know it's it.
We don't guess no. What? That's what. Number 7. Right? You have 5, 6, and the other two goes, right? 7 now, number 7. Huh? Look, I'm not using this group chat anymore, we're to be using the elements, right? Okay.
I know, hey, come on, you can chat, what, the same word.
Yeah, the 7 group.
But when you send it.
7 minus, I'll
Seven
send it.
minus, no.
Right, hurry up, do number 7. If I'm not mistaken, it should be close to this one, right? Oh, if I use 9.0, yes, the other direction. Darian, hurry up now, boy, last question. Number 7. It's very similar, yeah, very, very similar. You have a rescue team. Launches a supply package from a helicopter 100 meters above the ground. Package is projected with a velocity at an angle. How far horizontally will it land? So technically, what they asking for? Same thing again, right?
Yeah.
Same thing. They want R and T. Darian, trying to do a question. That's almost done. You're on the music look after. Right? Hey, you still only have 7 minutes a year, right? Hurry up. So you like people. Oh. Come on, hurry up now. Yeah,
Wait.
But then we'll get on about why. One thing I'm gonna write out what about it.
37 degrees.
Yeah, put some answers. So you come in here, you pull some I was doing like a movie. But yeah, we'll take someone. Yeah, you want to think about the shoulder, that's great.
So it's not a good job.
So you still have to go.
No, not video, I mean,
You want to use the phone?
yeah, I have to.
Yeah, but you don't have to find it, like, okay.
But you all got 3 times,
6.72.
that's not, I do something wrong. How much?
6.72.
6.72 here. So I got 6.72 time. What you got again? 6.72. You got it?
Yeah.
So your answer wrong for number 72.
Yeah, I feel some, I feel like send them something.
One, two, you want
So
I'll
I
do
guess
it
one.
I guess 6.72 for the
Yeah.
6.72 for time.
For R you get 161.
That's not, I'll do it now. One six one. 161. I'll probably check right now and then. So I got 161.
0.0 161 plus or minus what? That's it.
What's the answer I had there?
Yeah, 127 or something like that. Yeah, 17.
A bigger value right there, yeah. Like that.
So 161 plus or minus what?
Right so far? 171. Right? Okay, so those are your 2 values there. Are you okay with that? Right, it's just like the last one, just a number change a little bit, right? So I want you to recognize number 1, you have to learn to use the equations of motion properly, and number 2, get a nice diagram.
Yes, sir.
Okay?
Yes, sir.
Homework, finish the last 5, please.
No problem.
All right? Next day we'll go through those last 5, and then we take a look at terminal velocity and circular motion on it, right? Oh wait, no, we have done those to look at.